All right, guys, trigonometry functions. We have already reviewed what trigonometry is. The definition is right here. I'm not going to repeat myself. And a trigonometry ratio compares the length of two sides with respect to an acute angle theta in a right triangle. That's a mouthful. What does that mean? If you look at my diagram on the left, theta is right here, and that's one angle in a right triangle. You must have a right triangle to talk about trigonometry. So, and the trigonometry ratio is simply a fraction, as illustrated below, and that has various definitions of the denominator has to be one side and the numerator has to be the other side. So, and that gives you an idea of what trigonometry ratio is, right? It's two sides, in one side in the numerator, one side in the denominator. So let's look at some definitions here. Sine, if you can write it down, equals the opposite side of theta divided by the hypotenuse. And the hypotenuse, again, is the longest side that faces the right angle at 90 degrees. Cosine is adjacent side divided by hypotenuse, and tangent is the opposite side divided by the adjacent side. So if you look at it here where I highlighted, I wrote down SOHCAHTOA. That's how we remember it. So is sine equals opposite over hypotenuse. That's where the O and the H comes from. Cosine is CA. CA is cosine equals adjacent over hypotenuse. And tangent is the opposite side over the adjacent side. So that's how we got SOHCAHTOA there. If you remember SOHCAHTOA and you're gonna hear us talking about it constantly, you will not forget about the definition of sine, cosine, and tangent. Now, once you know the definition of sine, cosine, and tangent, look how easy it is for it to go over to cosecant, secant, and cotangent. Did you notice all I did was I flipped the denominator and the numerator so that sine and cosecant are reciprocals. So in other words, 1 over sine theta would give me cosecant, and 1 over cosine theta would give me secant, and cotan is simply 1 over tan theta. So this is called reciprocal functions. Obviously, it's a function because we have an equal sign there. And all I did was I flipped the numerator with a denominator, and I arrived at a new concept. So this is really important. Throughout the study of trigonometry, it doesn't matter what it is, even as hairy as it gets trigonometry identities very quickly in later chapters, as long as you understand sine and cosine, the remainder 4, you can derive everything out of that their relationships with sine and cosine. So even though trigonometry can appear to be overwhelming, as long as you understand sine and cosine, you already have known everything else. Everything else is a derivative of sine and cosine. All right, so let's look at some examples. Let me move this up. So find the exact values of the 6 trigonometry functions of theta. So I have a triangle that's 5, 12, 13. And if I want to find the sine of theta there, so theta, sine of theta is opposite over hypotenuse, right? So opposite is 12, hypotenuse is 13. That's it. And then cosine is what? Ca is adjacent of theta is 5, and then hypotenuse is 13. Tangent is opposite, which is 12, over adjacent, which is 5. Adjacent meaning that's an adjacent leg, right? Adjacent. if you don't quite understand what adjacent means, it just means if I have theta this way, I have two adjacent rays. I have two rays here, and they're both adjacent. However, in this case, we don't call 13 adjacent. Why? Because we call 13 the hypotenuse. So any right triangle, when we talk about adjacent, we're always talking about the two legs. In this case, one is 5, one is 12. Once we know this 3, all we need to do for the other 3 is to flip it because they're reciprocals. Cosecant is 1 over sine, so it's simply 13 over 12. Secant is 1 over cosine, so it's 13 over 5. And cotan is simply 1 over 10, so 5 over 12. Okay? So now let's look at number 2. Again, I have a right triangle. This time my theta, my acute angle, is here. So when I talk about sine theta, it has to be opposite, which is 4, over hypotenuse. My hypotenuse in this case is 4 root 5. If now you have to simplify it by canceling it, and I have 1 over root 5. Remember, root cannot be in the denominator. It's not fully simplified. And I'm going to do this here. To take the root out, all we need to do is to multiply another root 5. But if I do that, I'm going to change the value. I don't want to do that. So I stick a root 5 over on top so that I have a ginormous 1. In other words, I rewrote 1 over root 5 without changing its value. Without changing its value. This, whoops, sorry, I made a mistake there. This will allow me to operate root 5 times root 5 is 5, and then 1 times root 5 is on top in the numerator. That's my final answer there. Okay, that was a quick back of the envelope kind of review of how to get rid of a root in the denominator. You just multiply itself, but you have to put the self up in the numerator as well. So cosine is adjacent, which is 8, right? Adjacent leg over hypotenuse. Hypotenuse is 4 root 5. So that gives me 2 over root 5. And if you simplify that, that should give you 2 root 5 over 5. And tangent is opposite over adjacent. What's my adjacent? It's 8, isn't it? Yes. So if I simplify that, I have 1 over half. 1 over 2, right? So again, the other 3 is simply reciprocals of each. And to do reciprocals, I actually would go back to, it's easier to do reciprocals with these numbers right here. So the second one would be, if it's 2, yep, so that would be, what's that? That's 2 on top. So yeah, root 5 over, oops, it's all right if I don't change the color. Root 5 over 2. And the third one is easy. It's 2 over 1, which is just 2. Okay. Let's move this sheet up. Make it a little bit bigger. All right. So if you look at 3 and 4, it's exactly the same thing. The only thing that's different is I don't have a third side, right? I don't have a third side. So in order to calculate answer the questions about trigonometry ratios, you have to calculate the third side by using Pythagorean Theorem. Pythagorean Theorem. So c squared equals a squared plus b squared. A and b must be my legs. So 29 squared plus 20 squared equals my c squared. And then you have to take a square root of it. Oh, look at that mistake I made. I'm so sorry. Do you guys see the mistake I made? 29 is my c. 29 is my C here. So I cannot set this up this way. It's a very common mistake. I'm glad that I made that mistake. So C squared equals A squared plus B squared. C must be my hypotenuse. My hypotenuse is 29. And A is 20. B is my x squared. So if you do this right, you should have 441 equals my x squared. And if you take your square root, x equals 21. So this side equals 21. Now you can go ahead. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And now all you need to do is to flip it to give me the reciprocal. Done. Look how easy that is, right? So same thing with number 4. I'm not going to demonstrate number 4 for you. Key is online. And again, you want to, in this case, my x there is my hypotenuse. So I'll set it up for you. X squared should equal 6 squared plus 6 root 3 squared. Excuse me. And if you do your math right, x should come out to be 12. And then you can work off the rest of it. Okay? Okay. The answer for this is, let's see. First, for sine is root 3 over 2. And 1 over 2 and root 3. Two root 3 over 3 is cosecant. Secant is 2. And root 3 over 3 is the next. Okay. Now let's look at the next page. Use the given trigonometry value to find the remaining function values. For those things, actually really advice throughout math. Don't be afraid to draw. I am terrible. I flunked my art class at the age of 7, if you can imagine that. But it makes life so much easier if you just draw it all out. And I'm being lazy now, so I'll just draw all 4 out. Only because I know there are similar types of problems. So let's look at the first one. Tangent theta. So as soon as I see tangent, I know I have a right triangle here, and I have an acute angle called theta. Definition of tangent is opposite over adjacent. So opposite is 7, adjacent leg is 24. Voila, I'm pretty much done, because once I have that, I know my hypotenuse is c. C squared must be 24 squared plus 7 squared. Use your calculators, work it out. C squared should be, I'm doing the crazy mind math, but 625. I think that's, double check my arithmetic, okay? If you don't know Ms. Birch, you know Ms. Birch cannot do arithmetics. So check my answers. C should be 25. Now that you found the length of C, the rest of it should be exactly what we did previously. It's simply to find out the answers of the 6 trigonometry ratios. So again, I would pause the video now, try to do it on your own, and I will write out the answers here when you are doing that. So sine is 7 over 25. Cosine would be 24 over 25. Tangent is 7 over 24. And the rest of it is just a reciprocal. 24 over 7. That's it. Okay. I'm not going to do number 6. Again, key is online. Verify that with yourselves. Number 7 is exactly the same. I'm moving this up. So I will solve the side for you first. So I have a theta here. I have a right triangle. Cosine is cos, so it's adjacent, which is 5, over hypotenuse is 9. So if you do your Pythagorean theorem, it would be 9 squared equals 5 squared plus b squared. 5 is your a, your b is here. So that would be 49, 56. 56 square root is 2 root 14. Okay, once you have that, you will do the rest of it. And you know what, this time, again, I'm going to ask you to pause the video. I will do the same, and I will write the answers. So in the next second, you will see the answer of these two problems, 7 and 8. So pause your video. Okay, so I wrote down the answers for number 7 and number 8. As you can tell by now that the concepts behind it actually are very little. There's not that many concepts behind it, other than just the definition of sine, cosine, and tangent. And as long as you understand the concept, the type of problems are not that many. Either I give you 2 sides, ask you to find out the third side, and then give me the definition of the 6 trigonometry ratios, or I give you all 3 sides, and that makes life a little bit easier, right? So the calculation part of it is very tedious. The simplification of taking the radicals out of the denominator is where we often make the mistakes. So don't be intimidated by it. Trigonometry is really not hard. The hard part and the confusing part sometimes comes in the arithmetic of radical roots. Last concept of the unit, special triangles. It really is not hard. These trig values of special angles were covered in geometry as well. So, but I will tell you a secret. There is a secret hand signal in the math department. You all have to go to Mrs. Friedman to find out what it is. If you're not in one of our classes, make sure to reach out to Mrs. Friedman. She has a secret hand signal that helps you remember these. So for now, I'm not going to go through the laborious process of how you should calculate and all of that. I will just tell you the answers right here. So special right triangle, the first one is 30, 60, 90 degrees. And if I assume one side is x, and if you just remember it for now, the hypotenuse will be 2x, and then you can use Pythagorean theorem to find out the third side, which is the second leg of x times root 3. Okay, for 45, 45, 90, because I have 2 legs are exactly the same, and then you can use Pythagorean theorem to find out the third side. Now you all know three sides of each of the triangle. You simply start calculating. Sine of 30 degrees is opposite over adjacent. Cosine is adjacent over hypotenuse. That should give you root 3 over 2. Tangent is opposite over adjacent, so it's 3 root 3. And same thing with 45 degrees, that would be opposite over adjacent. And for 60 degrees, opposite over adjacent, opposite over hypotenuse, adjacent over hypotenuse, and then tangent is opposite over adjacent. Okay, once you know sine, cosine, and tangent, the rest is simply the reciprocal of it, and make sure you simplify it to give me these final answers. Don't just copy this down. You should calculate it on your own and verify your answers with this video. Okay, that's all for this unit. It's a lot of information. It's a lot of practices. There's also the homework page. Keys to the homework problems are always posted on PowerSchool Learning or phsmath.org. Okay, for this unit on phsmath.org, I posted as 5.4, but in your textbook is 4.2, so it's easier to go into your Power School Learning. All right, guys, I will see you back in class. Bye.